Hello everyone and welcome back. In this lesson, we will focus on automating the creation of hatch patterns in section views within Revit. One of the key limitations of direct shapes is that they do not automatically generate hatch patterns like native Revit elements. To overcome this, we will create hatch regions manually using the Add Region component. In this workflow, we will generate hatch patterns for three different types of elements: structural columns, base plates, and foundations. Each element type will have a distinct hatch pattern based on its material, and we will also assign specific line styles for better clarity. Additionally, we will add dimensions within the section view to enhance documentation accuracy. By the end of this lesson, you will have a structured approach to improving section views with proper annotations and hatch patterns. Since we have three different types of elements in our Revit model, we have created three separate workflows to manage them efficiently. One workflow generates regions for structural columns, another for base plates, and the last one for foundation elements. The first step is to extract the specific elements from Revit for which we want to generate regions. We do this using the category filter and query elements components. In this workflow, we extract only the columns from the Revit model. We can also visualize these elements using the graphical element component. At this point, we have all the columns, but we only need to generate hatches for those that are visible in a section view S2. To filter only those elements, we use the element view geometry component. This component takes elements and a view as inputs and outputs only the elements present in that specific view. If we check the output, we can see that only the columns in the current section view are extracted. Moreover, we only get the part of each element that falls within the far clipping offset. So by adjusting the section position and the far clip offset value, we can control which parts of the elements should be visible in the section. For instance, if we shift our section away from the grid, the entire column will be visible rather than just half, which is what happens when the section cuts through the middle of the column. At this stage, you may notice some empty branches in the data structure representing elements that are not present in the current view. To clean up the data, we use the Clean Tree component to remove these empty branches. Next, we extract the side faces of the elements using the BREP faces by direction component. This step is important because the Add Region component requires closed boundaries to generate proper hatch regions. Since we only need the faces visible in our section view, we isolate the relevant ones and connect them to the Add Region component. Once the inputs are connected, hatch regions are successfully created in Revit. To assign appropriate hatch patterns, we use the type input. For steel columns, for example, we apply a steel hatch pattern to maintain clarity in the drawing. For the base plate, we follow the same workflow but select structural connections instead of structural columns. The rest of the workflow remains unchanged. We extract the side faces of the base plate and use them to create the hatch region in Revit. In this case, we apply a solid black fill pattern for better visibility. Similarly, for foundations, we follow a similar approach. As seen in Rhino, only the part of the foundation inside the far clip region is visible. We extract the side face of the foundation to serve as the boundary for the hatch region, and then we apply a concrete fill pattern. Additionally, the Add Region component allows us to set a specific line style for the created region. For the foundation, we can either choose thin lines, wide lines, or any other custom line style. One key detail to note is that the invisible line style is not available in the standard list of options. Although Revit's UI allows us to manually assign the invisible line style, there is also a way to access this setting through Rhino.Inside. If you want to learn more about this, please refer to lesson number 3 under Add Region in the Annotations module. But if you are looking for a structured way to master these workflows and take your automation skills in Revit to the next level, I invite you to join our community. Inside the community, you will find exclusive insights, structured lessons, and direct discussions with other professionals who are streamlining their Revit workflows using Rhino.Inside. Whether you are just starting or refining advanced automation workflows, you will always find valuable guidance. Moreover, we provide dedicated learning modules, weekly live Q&A calls, and one-on-one mentorship to help you tackle challenges and accelerate your learning. If this sounds good, please check the first link in the description and become part of a growing network of professionals optimizing Revit workflows. Now let's get back to our lesson. Now let us move on to the final part of this workflow, which is generating dimensions in the section view. This workflow is similar to the one used for automating grid line dimensions. The extra step here involves using the Query View Elements component to extract only the grid lines visible in the current section, and then using the Element View Geometry component to obtain their precise geometry. Next, we use the Evaluate Curve component to determine precise dimension placement. Then we add detail lines, followed by the Add Aligned Dimension component to generate dimensions in the section view. One might ask why we use the Element View Geometry component instead of a curve container to extract grid line geometry. The reason is that a curve container retrieves grid line geometry from the planned view, not the section view. Since our dimension lines are placed based on grid line parameters in the section view, using plan view geometry would not allow the necessary adjustments. By using the element view geometry component, we extract the correct grid line representation from the current section, ensuring accurate placement of dimensions. Now we have successfully created hatch patterns and dimensions in our section views. And that's all for this lesson. In the next lesson, we will discuss how to create drafting views in Revit. Thank you for following along and see you in the next lesson.